Greetings, Abington families. This video is intended for district parents and guardians who are interested in learning more about the teaching and learning of mathematics in our secondary classrooms in Abington School District. Throughout this video, we will seek to explore three important questions. What will students learn in our mathematics classrooms? How will students learn in our classrooms? How will we know if students learned? At the secondary level, our mathematics curriculum is built around the Pennsylvania Core Math Standards, ensuring that students are gaining a solid foundation across the wide range of mathematical topics. This begins with numbers and operations, where students master concepts like ratios, proportional relationships, and number systems. As they progress, they'll dive into algebraic concepts, tackling expressions, equations, and functions, laying the groundwork for higher level mathematics. Trigonometry, pre-calculus, and even calculus allows students to learn about functions, limits, derivatives, and integrals. Additionally, geometry helps students develop spatial reasoning and an understanding of measurement and data, while statistics and probability play a significant role in preparing students to analyze data, make predictions, and understand randomness. We aim not only to meet these standards, but to go beyond them by encouraging students to apply mathematical concepts to real-world problems. This ensures they graduate with strong quantitative reasoning skills and are prepared to succeed. In addition to mastering content, Abington places a strong emphasis on developing key mathematical practices that build problem-solving and critical thinking skills. These practices are woven throughout the curriculum and are essential for students to become proficient mathematicians. We teach students to make sense of problems and persevere in solving them, helping them learn to approach challenges methodically. They are asked to reason abstractly and quantitatively, constructing viable arguments and critiquing the reasoning of others, which promotes deeper understanding and collaboration. Students are also encouraged to model with mathematics, using appropriate tools and strategies to represent real-world situations. Over time, we help students build habits through attention to precision and recognizing structure and patterns in math. These habits not only improve students' performance in mathematics, but also in other areas where logical reasoning and structured thinking are essential. By focusing on these practices, we ensure that students are not just learning math, but are learning how to think like mathematicians. Our instructional approach is designed to meet the diverse learning needs of our students and ensure deep understanding of mathematical concepts. Problem-based learning is a cornerstone of our instruction, where students explore concepts through real-world problems and engage in rich classroom discussions. This promotes a growth mindset and encourages students to think critically and apply their knowledge. Visual learning is central to our approach. We provide visual representations of key concepts, helping students to better understand and retain information. Whether through graphs, diagrams, manipulatives, and interactive tools on our Chromebooks, we make abstract ideas more concrete. This visual instruction is often connected to the problem-solving experiences, ensuring that students can see the practical applications of what they're learning. Finally, formative assessments guide our teaching. Frequent check-ins allow us to understand where each student is in their learning journey and adjust instruction accordingly. This ensures that students are prepared for high-stakes assessments while also fostering deep conceptual understanding. Most lessons are built around mathematical routines. We begin by recalling prior knowledge, activating what students already know so they're ready to connect new ideas. Then we strive to connect the lesson to real life, showing students how math is relevant beyond the classroom, like budgeting or calculating distances. Next, we provide explicit instruction where we clearly explain and model new concepts. From there, we move into guided practice where students try out problems with the support of the teacher and peers, asking questions and receiving immediate feedback. Finally, students move into independent practice, working on problems on their own to solidify their understanding. Teachers monitor student progress and give additional support if needed. Each lesson ends with a check for understanding and reviewing key takeaways. This routine helps students gradually take ownership of their learning while ensuring they have the support they need to succeed. In our math classroom, we also use two powerful instructional strategies: spaced practice and spiraling. Spaced practice involves revisiting concepts at regular intervals instead of cramming them into one lesson. By spreading practice over time, students strengthen their long-term memory, which helps them retain and master key math skills. The value of spaced practice is that it reduces forgetting and encourages deeper retention. By allowing time between practice sessions, students have a chance to revisit, learn, and ultimately master concepts. Similarly, we incorporate spiraling, where past math topics are revisited and interwoven with new learning. This method helps students build connections between what they've already learned and what they're currently studying. For example, when learning about geometry, we might integrate algebraic concepts to reinforce understanding and deepen problem-solving skills. Together, spaced practice and spiraling ensure that math concepts don't just get learned for a test and forgotten, but are built into long-term understanding, helping students become more flexible and confident problem solvers. In our math classroom, we use a variety of assessment strategies to ensure that we're continuously monitoring student progress and understanding. These strategies help us answer the essential question: how will we know if students learned? First, we use universal screeners, which are assessments given at the beginning of the year to help us identify students who may need extra support right away. We follow up with additional screeners at key points during the year to check on overall progress and ensure students are meeting grade level expectations. We also use curriculum-based assessments tied directly to what we're teaching in class. These assessments help us measure how well students are mastering the specific skills and concepts from our lessons. These can take the form of authentic tasks, where students apply their math skills in real-world scenarios, or common assessments, where students demonstrate their understanding in a test or quiz format. By combining these various assessments, we get a full picture of student learning and can make informed decisions to support their success in math.